Yellowstone Supervolcano is famous for its beauty, its geysers, and its bison, but it's also home to one of the largest renewable energy plants in the country. This geothermal plant harnesses the power of the earth to produce electricity from the supervolcano itself. And this could be the model for how we power our world in the future. In today's video, we're gonna go deep into the heart of Yellowstone to see what they've done there and how it can help us end our dependence on fossil fuels. There are over 10,000 geothermal power plants around the world. Most of these plants use steam that's been heated by hot rocks beneath the surface of the earth, but they only get their power from a relatively thin layer of earth near the surface, where water can turn to steam. The really hot rocks deeper underground are out of reach, so most geothermal plants can't access all of the heat that's available. They just aren't hot enough. But there's a place on Earth where the temperature increases faster the deeper you dig than anywhere else. That place is Yellowstone. Here, the ground is so hot it reaches 180 degrees Fahrenheit or 120 degrees Celsius at just 600 feet below the surface. And at 3 miles below the surface, the temperature is still increasing at a rate of 7 degrees per 100 feet. For reference, at that depth, the average geothermal gradient would only be about 4 degrees per 100 feet. So if you were to drill down into the earth at Yellowstone, you would find higher temperatures at lower depths than anywhere else on Earth. And that means that if you want to access deep geothermal energy, Yellowstone is the place to do it. Yellowstone's unique heat is thanks to its namesake, the Yellowstone Caldera, otherwise known as the Yellowstone Supervolcano. The caldera formed when a massive magma chamber was emptied during the largest eruption in North American history. Since then, it's been slowly refilled, and it's still a major source of heat today. In fact, Yellowstone produces more than 3 times its own internal heat from the decay of radioactive elements within the magma chamber. Because of this, Yellowstone is one of the most seismically active places in the United States. Hundreds of earthquakes happen here every year. So it might seem strange to build anything, let alone a geothermal plant, on top of such an active volcano. But there's a reason why they chose this site. See, in order to extract heat from the Earth's interior, you need to drill through the lithosphere, which is the cold, hard outer layer of rock. The problem is that beneath Yellowstone, the lithosphere is much thinner than usual. It's only about 3 miles deep, which makes it possible to drill into the hotter parts of the Earth's mantle. This is what makes Yellowstone such a perfect location for geothermal energy production. You don't have to drill very far to reach high temperatures. The first geothermal plant in the area began operating in 1985, and by 2026, it will be replaced by a new plant being built right now by the same company. It's called the Neal Roberts Plant, and it will use a technology called Advanced Geothermal System, or EGS for short. EGS allows us to harness energy from dry steam and hot water that wouldn't normally be accessible through geothermal. That's because traditionally, geothermal plants rely on finding areas where water naturally collects in underground reservoirs and turns to steam. But this isn't the case at Yellowstone, where the rock is dry and fractured instead of wet. EGS can make use of this kind of dry rock. This is done by drilling a well several miles deep into the earth and pumping water down into it at high pressure. Once the water reaches the hot rock, it's heated up and then pumped back to the surface, where it turns into steam. That steam drives a turbine which generates electricity. What's left over after the steam has done its work is still hot water that's pumped back down into the well to keep the process going. But there's a problem. Since the water is being pumped down into a space that wasn't previously filled with water, it needs to be filtered out before it can be reused. That's because the water carries with it a lot of stuff from the surface that can damage the equipment. So it needs to be clean. To solve this, the company behind the plant has partnered with a nanotechnology company to develop a system that filters out contaminants using membranes with pores smaller than the width of a human hair. These membranes allow water molecules to pass through while blocking larger particles like sand, clay, and bacteria. But one of the biggest challenges of building a geothermal plant in Yellowstone is not getting permission to build it. That's because almost all of Yellowstone is protected as a national park. so the construction and operation of any facility in the area must be approved by the U.S. Department of the Interior. Additionally, because the land is home to hundreds of species of plants and animals, many of which are endangered, there's a lot of environmental regulations to consider. For example, the plant must be built in a way that doesn't disturb local wildlife or impact air quality. But despite these challenges, the new Neal Roberts plant will be able to produce clean energy for up to 250,000 homes, while avoiding the emission of up to 500,000 tons of carbon dioxide each year. Now the question is, how can we use plants like this to change our future? Well, there are some hurdles that still need to be overcome. One of the main problems with geothermal energy is that it's not very cost-effective. That's because it's expensive to drill down into the earth and set up the necessary infrastructure. However, once the initial investment is made, the cost of producing energy is extremely low. In fact, geothermal is one of the cheapest forms of renewable energy available. Another problem is that geothermal plants can cause earthquakes. When water is pumped into the earth at high pressure, it can trigger seismic activity. This is rare, but it's important to remember that people live nearby. Fortunately, the risk of induced seismicity can be mitigated by careful monitoring and planning. But there is also an opportunity here. We could use these plants to dispose of nuclear waste from old nuclear power plants. Nuclear power is a great source of energy because it doesn't emit greenhouse gases. But it does have the downside of creating nuclear waste that needs to be stored safely away from humans. Deep geothermal systems could provide an ideal solution since they already drill deep holes into the Earth's crust. The holes can be filled with nuclear waste and then sealed off with cement. This would prevent any leaks and ensure that the waste is isolated from the environment for thousands of years. Not to mention that geothermal systems could also be used to store excess energy from other renewable sources like solar and wind. Whenever there's a power grid, you need some way to store energy. If we had a bunch of geothermal plants in different locations, we could take advantage of that storage capacity. That would help smooth out the intermittency of solar and wind power, making them more reliable. And we don't have to wait for these new technologies to start taking advantage of geothermal energy. There are already plenty of places around the world where it's cost-effective to build geothermal plants. In Iceland, for example, geothermal energy is used for heating buildings and greenhouses. In New Zealand, geothermal energy is used to generate electricity, and in Northern California, geothermal energy is used to power a dairy farm. With so many examples of successful geothermal projects, it's clear that this is a technology whose time has come. If we're ever going to end our dependence on fossil fuels and transition to a sustainable future, then we're going to need all the energy we can get. And fortunately, geothermal energy provides a reliable, renewable source of power that can be used 24 hours a day, 7 days a week. The technology to harness this energy has been around for centuries. All we need to do is build more plants like the one in Yellowstone. So what do you think? Would you support the construction of more geothermal plants in your area? Let me know in the comments below. Thanks for watching, and I'll see you next time.